Many products claim they can suppress thermal runaway. Today, we're putting that to the test. We're testing two products, a fire blanket and a cold fire extinguisher. For this experiment, we're using 170 individual 18650 lithium-ion cells, roughly equivalent to a hybrid vehicle battery pack. In perspective, the average electric vehicle contains over 2,000 of these cells. They're enclosed deep within the vehicle structure, making it nearly impossible for extinguishing agents to directly reach them. That's one of the biggest challenges first responders face when dealing with EV fires. In our setup, we removed all protective casings to expose the individual cells, creating an open cell configuration for controlled testing and analysis. We tried multiple ways to initiate thermal runaway. At first, we wrapped the cells with a heating element that gradually increased temperature, but that took too long. So, we switched to an external heating element burning at 450 degrees Celsius for over 30 seconds. By directing that heat onto specific cells, we quickly triggered thermal runaway. Our first test evaluated the manufacturer's claim that their EV fire blanket can control and suppress thermal runaway. The blanket significantly reduced oxygen to the fire, temporarily controlling the event. However, it did not fully extinguish the fire. In our second test, we examined the cold fire extinguisher and its claim to cut off oxygen and cool the cells. To ensure a fair test, we initiated thermal runaway in new cells that had not experienced a previous event. Using a thermal imaging camera, we monitored the cells closely. Once a cell entered thermal runaway, we encapsulated it and its neighboring cells with the cold fire solution. The extinguisher did an excellent job knocking down visible flames. However, our thermal imaging showed cell temperatures above 250 degrees Celsius, and a temperature rise in adjacent cells. We applied more cold fire and allowed time for it to cool, but temperatures continued to climb. We discharged the entire contents of the extinguisher, and while it knocked down flames, it did not cool the cells or stop propagation between them. It's important to note that our test used an open pack design, which actually benefits the extinguisher. In a closed pack, the heat would act like a convection oven, superheating nearby cells and accelerating propagation. In an open pack, the heat can dissipate into the environment, slowing that process. In conclusion, both tools provided partial control but failed to fully stop or cool a thermal runaway event. These results highlight the real-world challenges firefighters and first responders face when confronting EV battery fires.